So your online homework due tonight is 4.3 and 4.4. Talking about your finals here, so please pay attention. So final in this case is not comprehensive. It means your final doesn't cover from chapter 6 all the way till chapter 11. So your final only covers a few chapters, the last few chapters. So it will cover chapter 4.3 and 4.4. And also it will cover chapter 11, which is what we're going to go through today. So it's 11.1, 11.2, 11.3, and I think 11.5, 4 or 5. Let's see the last one, the binomial C. Oh, I don't have it here. So should be 11.5. Should have 11.5 in here. I was like, where is that chapter 11? It's not in here. Yep, 11.5. So it does cover. So in your finals, it will cover 4, 3, 4, 4, 11.1, 11.2, 3, and 5. So these are your finals only consists of these 6 sections here. So today we will cover chapter 11, 1. Yeah. So this is your finals. Your finals will be you can use 1 page of front notes. So this is back to the same that you have. So front page notes, you can use only 1 page. You can write whatever formula you want in this 1 page notes. You can type, you can write, big, small, up to you. But again, it's only the front page, and the page is going to be the standard size. So you can bring this 1 page note. You can use your calculators. You can use your, let's see if we can use, no, you cannot use a graphing. So I'll let you use a graphing here. I don't think so. You can see. Yep. I'll let you use a graphing calculator in your finals here. Okay, but class, make sure you show me the work when you do this. If you don't show me work because of graphing calculators, so make sure you show the works. Your finals are, as usual, when you do the tests, I break this into 2 groups, right? First day, Monday, is going to be from A to M, and then second day is N to Z or something else. I am not going to break this into 2 days because what happened is everyone wants to take it on second days. No one show up on maybe 1 or 2 of you guys show up on the first day. So I am not going to break this, and the class is getting smaller. So now your final in this case, if you look at the syllabus, we are not going to do it on Wednesday. So your final in this case will be on just Monday, the December 13th. Okay. So we will not meet on Wednesday, because the reason why is because if I meet on Wednesday and Monday, you guys, those students who take Mondays, they all want to take on Wednesday. So why I need to, and I can put all you guys in one day. So because the classroom is getting smaller now. So so your final in this case will be on Monday the 13th. Yep. So it's not going to be on Wednesday. So we don't have a finals on Wednesday. We don't meet on Wednesday. So this is your finals week. You only meet 1 time a day. And it is 12:30 to 1:30 in CLA 114. So this is going to be in CLA 114 from 12:30 to from 12 o'clock to 1:30. So this is where we're gonna do your finals. So you can use your graphing calculators, 1 page of notes, cover these 6 sections. It's gonna be on Monday, December 13th, CLA 114, 12 to 1:30. We do not have a finals on Wednesday, so do not come to class on Wednesday, the 15th. Okay, so we don't have that. So please, this is your finals in this case. Very important. So everyone will show up on that day. Questions? Your final is actually 25% of your final grade. So this final consists of 25%. So this is a big chunk. So I really want you guys to be successful in this finals. And the good news is this sections, chapter 4 and chapter 11, has no trigonometry. We don't do sine, cosine, secant, all those things. So this is mostly just algebraic here. So we do conic sections on 4s and sequence and series in 11. So we are only doing, so there's no sine, cosine involved here. Okay. Anyone have any questions for me? So chapter 11 is 11.1 is where we talk about sequence and series. Okay. So what is a sequence? A sequence in this case is a number that is having numbers like 2, 4, 6, 8, 10, so on. This is what we call as a sequence. A series is where you take this and you add them. 2 plus 4 plus 6 plus 8 plus 10 and so on. Okay, so if you just do the numbers without addition, we call that as sequence. If you start to add them, we call that as a series. Now, if you have a dot, dot, dot behind, this is what we call as an infinite sequence. And again, when you add, if you have dot, 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 that means you keep on adding. This is what we call as an infinite series. Okay. For finite series or finite sequence, you don't do dot, 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 means you do 2, 4, 6, 8, 10, and then dot, 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 and then 200. So that means that when you have a finite sequence, means we stop at a point. Okay, we start and then we stop. Same thing with a finite series. You add them, but this time you have a stopping place. So you stop at 200. Okay, so make sure you guys know the difference between infinite series and an infinite sequence, and a finite series and a finite sequence. So it's kind of very self-explanatory here. So so that is the meaning of it. When you talk about sequence, your sequence can be recursive sequence. What is the meaning when I say a recursive sequence? A recursive sequence means it's a sequence use your previous numbers. For example, will be your Fibonacci sequence. So Fibonacci sequence is what we call as recursive, which start with 2 ones and then 2 and then 3 and then 5. Does anyone know how the Fibonacci sequence works?
The previous 2 numbers added together?
Yes. So you have to start with the first 2 and then you add it up. So 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. Can you tell me what is the next one after 5?
8.
It'll be 8. Okay. Now, Fibonacci sequence always have to tell you what 2 numbers we start with. Okay. So when you have a recursive sequence, usually the recursive sequence will use, like they will say A0 is 1. A1 is 1, and then A2 is 2. So when you see this A comes out, this A is telling us the term or the numbers in the sequence. So A0 means it's your first term, or sometimes they use it. I'm going to see what is your book use in this case. So let's see what kind of. Do they use A0? They use A1. Sometimes they mostly use A1. They don't use A0. Yeah, I think they're gonna use A1 here. Yep, we use A1. Sorry. So we do not use A0. So we use A1. Sorry, my bad. So so when you see the letter A and the subscript 1, what does that mean? Is that reference to the first number in the sequence, so it's 1. A2 in this case means the second sequence, the second number in the sequence, and A3 means the third number sequence, and then this will be A4, A5, and A6. And yes, the last number that we do here is called the AN, which means that it is the nth of it. So so make sure you guys know what is the meaning of 1, 2, 3, and then 4, 5, 6, and then all the way till AN. Same thing happens in your this finite sequence that you have. This is considered A1, and then this is considered A2, and then so on. Okay. So in order for you to figure out the recursive sequence, this I can write a formula for it. So in this case, we know A1 is 1, A2 is 1. So if I want you to write this in the AN term, your AN term in this case is AN minus 1 plus AN minus 2. Now, what is this AN minus 1? AN minus 1 means is the one right before him. So for example, if this is AN, AN minus 1 in this case is the term right before AN. And then AN minus 2 here stands for the one right before him. So in this case, it's 5. So this is what we call as a recursive sequence. Means that means the next term is depends on your previous terms, and we use the n minus 1 and n minus 2 to telling us that the n1 in this case is the one right before it, in this case 8, and then n minus 2 will be 5. So we know the next one that we have in this case is, and we add because this time we add, so it's going to be 13. Okay. So, so this is how we figure out your Fibonacci, we call as recursive sequence, and one of them is called a Fibonacci sequence. Examples, we can also say, let's say that A1 is 3, A2 is 5, so it's not necessary to be always 1 and 1. Fibonacci is 1 and 1, but it can be any number we want. And let's say that AN in this case is 3 times AN minus 1 plus 5 times AN minus 2. So this is what we call as a recursive sequence, because you use back your previous 2 terms. Okay. So usually in your homework and in your test, if they give you a recursive, they usually provide you the first 2 terms, and they want you to find what is A3 and A4. So does anyone know how to find A3 in this case? So if you look at this formula, if I want you to find A3, means my n in this case is what? So if you look carefully here, your n in this case will be what? Will be 3. So now you just substitute all the n here to become 3. And that's how you figure out A3. So you got 3 times A2. So 3 minus 1 is 2. Plus 5 times A1, because 3 minus 2 is 1. So this, then what you do is you plug it in. So A2 in this case is 5. So this is 3 times 5, which is 15. Plus A1 in this case is 3. So 5 times 3 is 15. So in this case, your answer will be 30. Okay, so because we know A1 and A3, so we can plug this into your formula or your sequencing. Now, in order for you to find A4, so A4 in this case, if you refer to your formula, that means your n in this case will be 4. So if you change all this to become 4, then you guys get A4. So A4 in this case is 3 times 4 minus 1 is 3 plus 5 times A2 because 4 minus 2 is 2. So the A3 came from this. This is A3, the one that you found before. So it's 30. So that means 3 times 30. And then 5 times A2. A2 is the one given to us, in this case 5. So then you will get your answer in this case. So 3 times 30 is 90. 90 plus 25 is 105. So this is how you figure out your recursive sequence in this case. Guys, any questions? I will give you some examples here. So you guys try to do this on your own. So let's say that your A1 in this case is -2. And your A2 in this case is a -5. It can be negative, it's any numbers. And the sequence is given us by AN, recursive sequence, is equals to 3 times AN minus 2 minus 4 times AN minus 1. I want you guys to go ahead. What is A3 and what is A4? Yeah. Try to figure this one out. Anyone know how to find A3?
So I got 6 minus 20.
This is 3 times what?
6. Oh, -6. Okay.
-2. Yeah, watch out
Yeah.
for the negative. Yep.
Yeah.
Minus 4 times what?
Oh, it's -5. Okay.
Don't forget, I giving watch out carefully. Watch your sign. Okay. So what is this gonna give us?
14.
14. Right now we do A4. Anyone?
I got 3 times -5. minus 4 times 14.
So this will become A2. Yep, this will become -5. And this will become the one that we just used. We just found A3, which is 14. So as you know that it does have a domino effect. So that means if this number is wrong, your A4 automatically is wrong. Okay. So what is 3 times -5 minus this?
I got -71.
I think you guys know how to use your calculator to do this. So this is what we call as a recursive sequence. So make sure you guys be careful with the negative. So it can be negative, it's not always positive, and it can be fraction. So it's not necessary to be nice whole number like 2, 4, 6, 8. It can be a fraction. Okay. Next, we're going to talk about here is factorial. Factorial in this case means you multiply. So the factorial symbol we use is an exclamation point. So if you have an n factorial in this case is 1 times 2 times 3 times 4 times 5 times 6 times 7 all the way till n. Okay, so that means you stop at n. So this number is to determine where do you stop. Very special rule about factorial is 0 factorial in this case is 1. Okay, this is kind of like a fact or a formula. So a lot of people think 0 factorial is a 0, but unfortunately 0 factorial is 1. You can find the proof if you go to YouTube and search it, proof 0 factorial is 1, and there will be lots of proving about this. So make sure you guys know that. 1 factorial is 1 because 1 is only start with 1. 2 in this case is 1 times 2, so you get 2 factorial is 2. 3 factorial is 1 times 2 times 3. And again, when you multiply this, you will get 6. Okay, so 3 factorial in this case is 6. 4 factorial is 1 times 2 times 3 times 4. This will give me 24. 5 factorial is 1, 2, 3, 4, 5. Multiply them. So this will give me 120. So these are numbers that is very important for factorials. So if you see this kind of numbers, 1, 2, 6, 24, and 120, that is the factorial. This belongs to the factorial case. Okay, and yes, we can continue doing 6, 7, 8, 9, 10. But what happens to the n minus 1 factorial? So n minus 1 factorial is 1 times 2 times 3 times 4 times 5 all the way to times n minus 1. Now this one we cannot figure out the numbers because the numbers is n. So it's not like this 1, 2, 3, 4, 5 because then those are numbers. And then n factorial in this case is what we learned here is 1 times 2 times 3 times 4 times 5 times n minus 1 times n. So this is the meaning of n factorial, means you go all the way down to n, including n minus 1, because n minus 1 is the one before it. What happens to n plus 1 factorial? Plus 1 means you do an additional one. So it's 1 times 2 times 3 times 4 times 5 times n minus 1 times n plus 1. So in this case, when you have n plus 1, you have to multiply everything from the one previously, okay, all the way up to n. So I'm going to put this all in parentheses so you can see that, so you won't get confusing. Okay. So the reason why you learn factorial in this case is because of combinations. Okay, what is combinations? Combinations is telling us how many ways can you rearrange something. If you have, this many, for example, let's say you got 6 chairs and you got 3 people gonna sit on these 6 chairs. So how many ways can these 6 people sit on these 6 chairs sit on these 3 people? 3 people sit on these 6 chairs. So this is what we call as combinations. The formula for the combinations, they're all given in here. Oh, they don't have it over here actually. The combinations formula in this case is given us by NCR, where it is n factorial over by n minus r factorial times r factorial. So this is a combinations. Sometimes it can written down this as NR. Okay. Make sure you guys know this. The combinations. Your n in this case is always greater than or equals to r. Okay. So your n is always either greater than or equals to r. So for example, is that we got 6 chairs, right? And you got 3 people sitting. So what is the, how many ways can we do this? So in order for us to do this, you just figure out which one is n and which one is r. So in this case, your n in this case is 6 because it's always greater. Your r in this case is 3. Okay. So this is called as 6 choose 3. So we use the word C, stands for choose or combinations. So this one is going to be 6 factorial over by 6 minus 3 factorial times 3 factorial. So this is n minus r, so you subtract these 2, and then the last one is r factorial. So 6 factorial means you multiply 1 times 2 times 3 times 4 times 5 times 6. 6 minus 3 is 3, so this is 3 factorial. So 3 factorial means it's 1 times 2 times 3. This is 3 factorial. You got another 3 factorial from here. So you also need to multiply 1 times 2 times 3. So don't forget, you got double 3 factorial. One came from the first one and the other one came from the other one. And we can start canceling because they are multiplying. So the 1, 2, 3 can be canceled. The 1 is redundant because anything multiplied by 1, you get the same thing. And we know 2 and 3 is 6. So 6 can be canceled with this 6. So how many ways can you arrange these 6 chairs for these 3 people want to sit on the 6 chairs? Your answer in this case is 20. So there are 20 ways for you to arrange this. 20 ways for you that 3 people sit in these 6 chairs. You guys all right? Combinations is used a lot in probabilities. The reason why is because when we do probabilities, we talk about combinations. These combinations can be done by probabilities. As you know, probabilities can be done like poker game, blackjack, all those casino stuff. They're all asking for probabilities. And in order for you to find the probabilities, you have to figure out the combinations. Means how many ways can it happen? Like blackjack. How many ways can it happen in the deck of cards? Okay, and I do not want you guys to take a deck of cards and start, playing with it. Oh, there are this many ways. You can do it, but it will take you a long time. But then we will use this kind of combinations. Okay, and again, class, you are just going through a very, very basic. You're just learning this, so you are just stretching the surface in this case. Okay, so just bear in mind, and you will use this in 11.5 when we talk about binomials. I will tell you more about that. Next, we will talk about, so this is all about sequence, and yes, you can get it all over here. So we talk about finite, infinite sequence, recursive sequence, factorial. We're going to talk about summation later on here. So, so let's do the first example here. Okay. So this first example is given us by an equals to 1/2 n. And the question wants us to find the first 5 terms. So this is very easy. So in order for you to find the first 5 terms, you put n equals to 1, 2, 3, 4, 5. So a1 is the first term. So you put 1 in here. Your answer in this case is half. Okay. A2, you put n is 2, so this will be 1/2 squared. So this is 1/4. And you repeat A3 is 1/2 cube. This is 1/8. And then this is easy. This section is actually not difficult. So in order for you to find, because the question wanted us to find the first 5 terms, so you're gonna go all the way to A5. So this is actually is 1/2 to the power of 4. Anyone know what is 1/2 to the power of 4 is? Anyone know 1/2 to the power of 4 is?
1/16.
1/16. And A5, 1/2 to the power of 5, which is 1/32. 32. Okay. Now this is easy, right? This is like same thing happens in question 2 and 3. You just need to plug n become 1, n become 2, n become 3, n become 4, and n become 5, and you will get your answers. Don't forget the factorial in this case. You just need to multiply them. Okay. So this is pretty much straightforward for this. But so if I give you the an and I want you to find the first 5 terms, it's super easy. But what happens if I give you the first 5 term, which is 1/2, 1/4, 1/8, 1/16, and 1/32? Can you tell me what is your an terms? So we do it backwards now. So we know the answer in this case is here, 1/2 to the power of n. But let's say you do not know all this. Okay. The answer is this one. So how do we know this? So how do I teach you guys? Because this is the one that a lot of students get wrong in my finals here, is because I don't come this way. Like question 1, because it's too easy, I will do like this question 4, okay, where I give you this kind of the sequence. You have to tell me what is your an term. So what do I do in this case, class, is I will label this as 1, 2, 3, 4, 5. Okay, because we know we start from 1. Now, since every one of these has 1/, so we know that our formula for this case is going to be 1/. Okay, and now you need to figure out what happens in your denominator. So you have to figure out what makes this become 2, 1 become 2, 2 will become 4, 3 will become 8, 4 to become 16, and 5 to become 32. So by looking at, a little bit tricks here. So this is actually going to be 2 to the power of 1. This is 2 to the power of 2. This is 2 to the power of 3. This is 2 to the power of 4, which is 16. This is 2 to the power of 5, which is 32. So that means your power here, 1, 2, 3, 4, 5, match with your n, 1, 2, 3, 4, 5. So in this case, that this follow will goes to 2 to the power of 3. 2 to the power of n. Okay. So that means that when your n is 1, you get 1/2. N is 2, you get a fourth, an 8th, 16th, and a 32, and so on. So this is how you figure out the backward style. This is the one that is the tricky one in the test. So this is what we call as write an expression of an. Okay. So now I'm going to test you guys to do number 5. Yes, this is something that 0, 3, 8, 15, 24, and so on. So what is your an term? So we're going to put this is 1, 2, 3, 4, 5. Anyone? tricky. Anyone know how to do this? Again, this is something that is outside the box. I cannot teach you. This is, you have to think it. Anyone know what that sequence looks like? See, once I show it to you, say, oh yes, I got it. That's what happens in your finals because there's no one shows, there's no help button here. Anyone? Still waiting. You guys have to think. Anyone got any ideas? Tough, huh? Anyone know how to get 1 to become 0, 2 become 3, 3 become 8, 4 become 15, 5 become 25, 24. See, I'm worried about your test now. Okay, we'll come back with number 5 because I do not want to give away. Because if I just tell you the answer, you'll be like, oh, okay. Let's take a look at number 6.
N squared minus 1.
Yes, this is n squared minus 1. Thank you, Logan. Is that Logan or?
Yeah.
Yep. So that means that if you square this, if you square this, this will become 1, 4, 9, 16, and 25. And then after that, you subtract 1. And once you subtract 1 on it, this will become 0, 3, 8, 15, and 24. So this is your formula for this case. Yep. So don't forget, you can square it, you can n square it, you can cube it, you can, factorial it. Okay. So now let's take a look at question 6. So question 6 is a fraction. So that means your answer is going to be a fraction. So I'm going to do this 1, 2, 3, 4, 5 here. So let's take a look at the top one. So can someone tell me how you write 1 to become 2? 2 become 3, 3 become 4, 4 become 5, 5 become 6.
1.
So you add 1. So in this case, we know this will be n plus 1. So the top one in this case is n plus 1 because you add 1. So if n is 1, you get 2. If n is 2, you get 3, and so on. Okay. Next, the bottom one. So you got 1, 1, 2 become 3, 3 become 5, 4 become 7, 5 become 9.
Would
And
it be n plus 2?
n plus 2?
Yeah, for the bottom.
So let's check it. So when n is 1, what is 1 plus 2? Do you get 1?
No, you get 3.
Oh, so this is no good. Good try.
N times 2 minus 1.
That means 2n minus 1. So n times 2 means 2n, right? 2n minus 1. Again, plug it. 2 times 1 is 1. 2 times 1 is 2. 2 minus 1 is 1. Okay, that's good. 2 times 2 is 4. 4 minus 1 is 3. 3 times 2 is 6. 6 minus 1. So this is correct. This is 2n plus 1. Okay. So here is the hint. So there are some hints I want to point out to you. So if you have odd numbers, 1, 3, 5, 7, 9, so on, odd sequence. Your term in this case is always 2n minus 1. Sorry, not 2n plus 1. It's 2n minus 1. Okay, it's always that way. Okay, so if you see something in the odd numbers, what happens when you have an even numbers like 2, 4, 6, 8, 10? Then your sequence in this case is called 2n, because when n is 1, you get 2, n is 2, you got 4. Okay. So make sure you guys know this. This is very important. Okay, so this is your answer for question 6. I'm going to do for question 7, and in this case is 1, 2, 3, 4, 5, and 6. So I'm going to write this all over 1 because they all have fractions. So if you in your test or in your homework, if the first two have no, if all of them have fractions beside the first few terms in the beginning, just make it over 1 so that you guys can see your pattern here. So now we need to figure out how you get 1 to become 1, 2 become 3, 3 become 3 squared, 4 become 3 cubed, 5 become 3 fourth, and 6 become 3 fifth. So we do the top one. Look at the pattern. This all has a power, right? What is the base of this?
Is it 3 to the power of n minus 1?
Yep. So this is a lot of certain things. This is 3 to the power of n, but you can tell that this is not good because you notice that your power is not exactly the same, because when n is 3, your power is 2, right? So that means your power is reducing by 1. So this is n minus 1. So when n is 1, 3 to the power of 0, does anyone know what is 3 to the power of 0 is?
It's 1.
Is 1. Okay, so that's why you get the 1. And when n is 2, is 3 to the power of 1. That's why you get this. Okay, and then when n is 3, you get 3 squared. So this is correct for the top one. Now at the bottom one, this is a tricky one. 1, you get 1. 2, you get 1. 3, you get 2. 4, you get 6. 5, you get 24. 6, you get 120. So what makes him have this? Something you need to think about. Anyone?
It has to do with a factorial, I think.
Very good. Okay. So I'm going to show you the factorial. This is the factorial that we just did just now. If you look at a factorial, we got 1, 1, 2, 6, 24, 120. So these numbers actually match with this. So, but you cannot give me n factorial. The reason why you cannot give me n factorial in this case is because 1 factorial is 1. But what is 2 factorial? 2 factorial is 2. So it's not matched with this. So actually, if you look at this, it starts from 0 factorial. So when you do the n factorial, this is considered wrong. So what we do here is we do n minus 1 factorial. So we try to make this as 0 factorial, 1 factorial, 2 factorial, 3 factorial, and so on. So in order for us to make 1 to become 0, I subtract 1. So 1 take away 1 is 0. So you get 0 factorial, which is this one. And 2 minus 1 is a 1 factorial. So you will get him, and then so on. So this is the n factorial. But if I change this to become the bottom one, I become 1, 2, 6, 24, and 120. That means it doesn't start with 2 ones. You only start with 1. Then this is going to be n factorial. Okay. So that is another thing I want to point out here is factorial. So if you have 1, 2, 6, 24, and 120, this is n factorial. This is something that you guys need to know. And if you have double ones, then you will have n minus 1 factorial. So you have 1, 1, 2, 6, 24, and 120. So this will be n minus 1 factorial. Okay. So just so when you guys do sequence and series is what you notice the pattern, right? Because you let's say 2, 4, 6, 8, 10, you know the pattern. But some patterns you are not familiar with, like this factorial pattern. So make sure you guys understand these are the patterns for and how do we represent this in n. That's how we represent this in n form. Anyone have any questions here? Okay. So this is all about sequences. Okay. So as you know that this section consists of 2 parts, sequences and series. So what we talk about here is mostly sequences. So we talk about series just a little bit. So series is like sequences. Instead of giving me like the term, comma, comma, you add, right? So it's like 2 plus 4 plus 6 plus 8. This is what we call as series. And if you have a dot, 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 this is called an infinite series. And then if you have an ending, like 200, like what I just said, this is a finite series. This is what we talked about early on. So when you talk about series, when you start to add, we will have used this big summation notation. Okay. This summation means you add. And usually in this summation, you got 2 numbers, n equals to 1 to k. Okay. So what is telling us here is this means is where you start adding. And this is where you stop adding. And then you put your AN sequence here. So remember on the previous example, like question 4, 5, 6, 7, 8 here, we found the AN series, right? So you have to put that AN series over here, and you have to give me this big summation, and it's telling us where do you start. Usually we start from 1, and where do we stop? So let's say that you want to add this all the way till 200. So if you add 2 plus 4 plus 6 plus 8 plus all the way till 200, can you tell me what count do we stop? So this is n is 1, n is 2, 3, 4. Can someone tell me what happens to 200? What is your n in this case?
Is it 100?
And that's
100. Okay. And can you tell me what is the AN form for this? Remember last time 2, 4, 6, 8, 10. What is your AN that you want to write down? This is written down as 2n. So how do we write this in a summation form? Is your AN is 2n because you double all your terms. You start it from the first term and you add it on what? The 100 term. Okay, so this is a finite sum. 2n means you add 2, 4, 6, 8, 10 all the way from 1 till 100. What happens if you have an infinite series? then your summation is still gonna be the same, where n in this case is 1, but this time this will go to infinity. So this is the infinite series, means you stop at the infinity. You don't stop at 100. Okay. Sometimes also, instead of adding 2, 4, 6, 8, 10, I want you to add 8, 10, 12, 14, all the way till 200. Okay, so how do you write this summation? Don't forget, it's still 2n because everything is down, right?
So would 200 be on the top and then
No,
8 would be-
you don't add till 200.
would
Forget.
199 be on top?
So you'll be 100 on top.
Okay.
And you start from where?
4.
4. Yep.
Okay, so you divide everything by 2.
Yep. Now this is only happens when you have what? 2, 4, 6, 8, 10, right?
Mhm.
Okay,
Yeah.
so this is how we do this kind. So when you guys do what we call as a series, you have to use the summation. So the summation needs 3 things: where it starts, where it stops, and the an terms. Okay, so if you know this, then you can plug it in there. Okay, now so this is called a summation symbols. Okay, we have some so we call this as an upper limit. This is a lower limit of summation. So and the index. So they use I here and I use n. Again, they are variables, so don't worry about that. What happens that if you are adding a constant? So the first property of summation you have is you add a constant. So adding a constant means you add the same number. So what happens when you add 5 plus 5 plus 5 plus 5 plus 5? Let's say you add it 100 times. Okay, so this is the meaning of the summation of n is 1 because you start from 1 and you go all the way to 100. Now, since they're all 5, 5, 5, 5, 5, your an term in this case is 5. Okay, so that is if you have a constant means a number that is repeated the same. So what happens in this case for the first property of summation? If this number c is a constant, so this is actually you just take this n 5 times 100. So this is 500. Okay, so so this is your the first property says if c is a constant means they are all the same number, and you've been adding it 100 times and how many times you want. This is how you write your summation for this case. And for us to calculate this, you just multiply them. The second properties of summation says that if your term is being multiplied by a constant, let's say I have 5 plus 10 plus 15 plus 20 plus 25 plus all the way to 100. Okay, so what we can figure out is if this one, if you look carefully, is if you factor out 5, you get 1 plus 2 plus 3 plus 4 all the way till 20, right? Because 5 times 20 is 100. So how do we write the summation for this? The summation in this case is you start from 1 and you go to 20 because the n number is 20, and this is 5 times an. So this is the an. Since this an start with 1, 2, 3, so this is just n. So this is called 5. So this second property says that if you have a constant, okay, this constant, which is a 5, means you multiply, you factor out the 5. This 5 actually you can take it out. So that means it won't affect, this 5 will be taken out, and you will still add 20 to 1 for n. Okay, so this 5 is a constant you can take out from the summation. So this is what the second property says. Okay. The third property is when you have two sequences. Okay, so for example, in this case will be let's say you got two properties. Two sequences. Let's say the first sequences, you add the odd one, 1 plus 3 plus 5 plus 7 plus 9 and so on till, I don't know, 21. And then the other sequence is an even one, 2 plus 4 plus 6 plus 8 plus 10 all the way till 30. Okay. So in order for us to find the summation of this, so when you want to find the summation of this that you need to add, okay? So you can actually, usually this is the same. So this is how many terms we have from 21? 2n minus 1. This is 10. So this should be up to 22. This one, if you do, sorry, they have to be the same term here. This is 2n minus 1, because your term is it 2n minus 1 or 2n plus 1? I always forget about what is that gonna be. Where is my formula that I showed to you earlier? Up 2n minus 1. Yep. So if it's odd 1, 2, 3, it's 2n minus 1. So we have to figure out what is your n here. So this is n is 11. So in this case, this has to be n at 22, okay, not 30. So it has to be the same n. So what is going on in this sequence? It was telling us that you want to add this from n is 1 till 11, because 11 is, for this term, will be 11th term and this 11th term. So you can actually, instead of adding this will be 3 plus 7 plus 11 plus 15 plus 19 plus all the way, and then plus 43. And then you add all this up. You can do it that way. So this question is saying that you can add all this up first and then add them. Or you can separate this into two. So that means you just add the odd one first, and you add the even ones next. So this is the meaning of the third summation property. Is if you want to add two sequences, you can add them together first, then add everything after that. Or you can add the sequence first, and then after that, add the total. Okay. Same thing with subtractions. If you want to subtract this 2, that means 1 take away 2 is -1, 3 take away 4 is -1. Then you find out this is all -1. You can actually add all this first, and then you subtract that. So this is the fourth formula here. So that means that for the properties of summations, you can either add first, then you find the summation, or you sum them first and then add them up. Or same thing with you find the difference and then you add them up, or you add them up and then take the difference. So this is the summation properties in this case. Okay. So mostly you will see this in calculus 2 when we talk about summations. Okay. And finite and infinite series is what we talked about just now. Finite means it stops. Infinite means it keeps on going. Okay, so we'll do some example in this case, number 10. So you need to find the sum when I equals to 0 to 4, I squared. Now, because of I don't know what happens to my the Word document. So when I write something like this in your I will write this in your test. This means something like this. I don't know why they put the I equals to 0, 4 next to it. It should look something like that. Okay. So how do we do this kind of questions? Is first you replace your I becomes 0. So you got 0 squared. And then you replace I to become 1, y 1 squared. I become 2, 2 squared. I become 3, 3 squared. And I become 4, 4 squared. And we stop at 4 because the summation here says you stop at 4. And what you do is figure out what is 0 squared, what is 1 squared, 2, 3, 4 squared. And then after that, you sum them up. So this is how we do this kind of summation. So 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. And don't forget, add them up. So what do you get when you add all this up? You will get 30. Anyone have any questions? Okay. We're gonna do the same thing for question number 13, where you need to find to the fifth partial sum. What's mean by fifth partial sum means that this, if you look carefully, it goes to infinity. So when I ask for fifth partial sum means you add all the way up to 5. Okay. So this question number 13, they want you to find the fifth partial sum. What does that mean is you add all the way up to 5. Okay, the fifth means 5. So in this case, it's the same thing as number 10. You replace I become 1. What you get here? So you will get 2 over 3. Okay, so 2. I equals to 2. So this is 2 times 1 over 3 squared. What do you get when you take this? 2 times 1/3.
You get 2 over 9.
9. Yep. And you have to do this for 3, 4, and 5. Yep. Please do it. Because the question asking for the fifth partial sum. So that's why we stop at 5. Anyone got the I equals to 3? Two over by 27. The fourth is 2 over by what? You can look at the pattern. The pattern is increasing. 3, 9, 27. Anyone?
Isn't it 81?
81. Yep, that is 3 to the 4th. And the last one, 2 to the 2 over by what for 5th?
243.
243. And the word sum is involved. So means you will have to take all these icky fractions and what you do. You have to sum. You get your calculator, right? You get your calculator and add all this. And that's what we call as the fifth partial sum in this case. You guys know to use a calculator here. I want to take attendance here, so please put present in the chat room. Now, next is we want to write this sigma notation. So this is, I'm just jumping around here. So I think you guys know how to use a calculator to add these fractions, right? Pretty much. I think you can do that. Okay. So make sure you guys know the meaning of fifth partial means I want to add up to 5. This means I need to add up from 0 to 4. Okay, the sum. Question 11, 12, in this case, you need to write in the summation notation. So you will see this 5, 1 plus 1, plus 5, 1 plus 2, plus 5, 1 plus 3, plus all the way till 5, 1 plus 5, 15. So can someone tell me what is your AN terms here? So N in this case is 1, 2.
And that's terms 1 through 15.
You have to write in the so this this goes to 15. Yep. So what is AN term for this case?
5 over 1 plus n.
Yep, 5 over by n plus 1 or 1 plus n, the same thing. Okay, so now we this is not your answer. This is your AN term. Now we need to write this in a summation form. So what number do we start from here? We start from 1. And where do we end? We end at 15. And then the AN in this case is 5 over n plus 1. So this is your answer in this case. Okay. So again, in order for you to write a summation, you need 3 things. What number do we start from? What n terms we end? And then what is your AN sequence? So if you know this 3, you just put it in here and that is your answer. And usually in your online homework, they want you to put the parentheses around. Just, you know, I'm not picky, but your online homework is. So this is a little bit tricky. 3 minus 9 plus 27. Now you find out the first thing is your sign is alternating from plus to minus. The good news is we know that n in this case starts from 1, 2, 3, 4, 5, 6. So we know that it ends at 6. So the sum notation is we figure out it starts from 1 and it ends at 6. So this is because you got 6 terms here. And the difficult part is not figure out the sum, is figure out the AN here. Because if you know your AN, then you should know then you'll be able to put it in here. Okay. So this is something I want to point out to you guys. Remember, there is a formula to find n here. Okay, this is a formula. So we're gonna add a little bit more to that formula here. So let me save this so you guys can. So this is something extra. Okay, so if you have alternating sign, that means from positive to negative to positive to negative to positive to negative, then your AN term in this case will be -1 to the power of n minus 1. Okay, so if you have a plus, I mean, this is just for the sign. So if your sign is alternating plus minus, then this will be a -1 to the power of n minus 1. Again, when n is 1, so 1 minus 1 is 0. So anything power of 0 is 1. So you got a positive. When n is 2, you got 2 minus 1 is 1. So -1 to the power of 1 is -1. So you will use a -1 to the power of n minus 1 for this alternating. But if your alternating is on the other way, means minus, plus, minus, plus, minus, plus. So don't forget, alternating can be the other way. Then your formula in this case will be -1 to the power of n. Okay. So make sure you guys know, if a plus come first and then minus and plus, this is the alternating symbol. But if minus come first, then plus, then that will be your alternating symbol in this case. Okay. So this is used a lot when your sequence has plus, minus, plus, minus. Okay. So now we look back at this question number 12. So since this is a plus, minus, plus, minus, plus, minus, so this sequence will have -1 and -1. Now this is just for the sign only. Okay, the plus, minus, plus, minus. So when n is 1, you get 1. When n is 2, you get -1. When n is 3, you get a positive, because 3 minus 1 is 2. Square it, get positive. When n is 4, you get -5 and 6. So this is just to take care of your sign. Now, can someone tell me how you do 3, 9, 27, 81, 2, 4, 3, and 7, 2, 9? Now we're talking about these numbers.
Is it n to the power of 3?
So this is n to the power of 3, because when n is 1, you get 3, n is 2, you get 9, and so on. So this is your an term. The blue one is for your sign, plus, minus, plus, minus, and the red one is for your numbers. So this summation is actually this -1 n to the 1 times 3 to the n. So this is your answer for question 12. Tough? Don't forget, this kind of stuff you will see a lot in calculus too. So you will be kind of tired of seeing this when you go to Calc 1, you don't see it. Calculus 2, you'll be doing this a lot. Because calculus is mostly on sequence and series. Yep. Last one is number 14. They want you to find the sum of this. Okay, it's not K, it should be I. It should be a typo there, should not be K, because the term here is I and what K. So it's I in this case. So you have to find the sum of this case. So in order for us to find the sum, and don't forget, this sum is infinity. So that means you keep on adding. Now, the good news is the 7. So this 7, you can take it out, because the summation notation says if you have a constant, so this constant, you can take it out. So you still need to find what is this one is. Okay. Now, for this, if you look at the sum, so let's say you put I equals to 1, you get 1/10, right? Because 1, you get 1/10. If your I is 2, you square it, right? You get 1/100, because 10 times 10 is 100. And when you do 3, you get 1/1000, because it's 10 times 10 times 10. Now, if you replace all this fraction to become decimals, this is 0.1. This is 0.01. This is 0.001. And again, when you do I is 4, you get 0.0001. And you do the same thing till infinity. Because this is sum to infinity. This is 0.00000001. Now don't forget, the sum here means you have to what? Take all these and add. Do you know what happens when you add all this? You get what? 0.11111111. Repeat. So this is the sum. If you want to write the summation of a repeating decimals, you always use the infinity, telling us that it is repeating. And then the 0.1 came from this 1/10. Okay. And don't forget, we need to multiply this by 7 because we have a 7 in front. So this is 0.77777777. Can you tell me what is this fraction? Anyone know what is 0.77777 in fraction?
7/9.
Yep, 7/9. Okay. So I want to point out, this is very important, especially you go to calculus 2. The summation of infinity from 1 to infinity of 1/10, this is actually is 1/9. Okay. That means if you take your calculator and punch 1/9, you will get all this decimal 0.111111. So if you have a 7, you just need to change that 1 to become 7. That's it. So this is how you find the summation of this infinite series. So again, a very important class. If you get this, it is mean 1/9. Okay. There is also, you guys know what is 0.33333, right? What's that in fraction?
1/3.
1/3. So this, if I want to write this in a summation form, this summation will look like I equals to 1 to infinity 3/10 to the power of I. So this is the same as him. The reason why it's 3/10 is because 3/10 is 0.3. Okay, you got a 3 in here. So when you got 3/100 is 0.03. When you got 3/1000 is 0.03003. So when you add all this, you will get the 0.33333. So that's why you just change that 1 to become 3. You get all the 0.3s. Okay. So this is how we write that in the sequences. Okay. Questions for me? Now we're gonna stop here today. So, but on Monday we're gonna do double works. We're gonna talk about arithmetic sequence and the geometric sequence. So these two are not too difficult. I will kind of go through this very quick on Monday because arithmetic means addition. So like 2, 4, 6, 8, 10. Or you add a number or subtract a number. Geometric means you multiply by a number or divide by a number. So I think we'll concentrate more on Monday. We concentrate this too. Again, it's not difficult, so I would recommend you guys to really learn this, and it's easy to pick it up. Okay, compared to your trick stuff that you learn in chapter 6 and 7, 8. Okay, so on Monday we will do a little bit of arithmetic and a little bit of geometric. So mostly I will concentrate more on the word problems here. The arithmetic and the geometric word problems. So I do want you guys to brush up a little bit on this. It's kind of straightforward. There are formulas. So the big thing about these two sequences, the arithmetic and the geometric, is the formula. I can highlight the formula here for you. So for the arithmetic sequence, if you want to find the nth term, this is the formula. An equals to a1 plus n minus 1d. A1 is your first term. D is your common difference. Common difference means what is the difference between from like here 5,3 to 5,7. the difference here is 0.4. And then 5, 7, and 6, 1, the difference here is also 0.4. So that means the D in this case is 0.4. The common difference. If you want to find the sum of this finite arithmetic sequence, means you add them up. Your formula in this case is Sn equals to n over 2, a1 plus an. Okay, so this is the formula for arithmetic sequence. The formula for the geometric sequence is given us by a common ratio. So we don't use difference because difference is for arithmetic, ratio is for geometric. So the nth term of a geometric sequence in this case is given us by the formula of an a1 times r to the n minus 1, where r in this case is called a common ratio. How do you find your common ratio? Is you take the second term divided by the first term. Okay, so this is called a common ratio. And in order for you to find the sum of the finite geometric sequence, you should look something like this. And the formula in this case is given us by a1 parentheses 1 minus rn to the power divided by 1 minus r. And we also have a geometric series for infinite geometric series. As long as your r is less than 1, the sum in this case is given us by a1 divided by 1 minus r. Okay. So this is one is for infinite and one is for finite. Finite means it stops, infinite means it's continuing. So we'll talk more about these formulas on Monday class. Again, these are the form. If you are doing your preparing for your finals, these are the formulas I would really suggest you guys to transfer it to your one-page notes here. Okay. All right, so that's it for today. You do have 2 homeworks due on tonight, which is 4.3 and 4.4, and then start working on the 11s here. Anyone have any questions for me before we end today's class?